So at this point, the app is basically finished. It works the way it should, we can complete our tasks, and we can add new tasks. But the code base can actually be improved and should be improved. Because at the moment we're managing all our tasks and all the logic for manipulating those tasks in the tasks component. Which on first sight makes sense, right? It's the tasks component, so it makes sense to manage tasks in there. But actually, when working with Angular, it's considered a good practice to keep your components and their classes as lean as possible. And managing some data like these tasks here, which are actually used by multiple components. After all, the new task component, for example, adds a task, and the task component deletes tasks. If you have situations like this, it's typically recommended that you use a service for managing that data. And services are another crucial feature in Angular every Angular developer must know about. That's why we will now build such a service. So how do we build a service in Angular? Well, it typically starts by creating a new file because just like components or models, services should live in their own files. Now here I plan to create a service that will manage my tasks, hence I will create that service in the tasks folder next to the tasks component. So it's there where I create an extra file, and I'll name that file tasks.service.ts. I choose tasks because we'll be managing some tasks, and then the type of the file, so to say, is service because we'll store a service in there. Now, what is a service in Angular? Well, it's just another class, and I'll name it tasks service. And at this point, it hopefully also makes sense why you should name your component classes like this. Why you should include the word component in their names. Because these are not the only kinds of classes you'll be working with. Instead, a service is also a class, and hence it's named tasks service here. Now, the idea behind such a service then typically is that it performs some operation and or manages some data that might be needed by one or more other components. So in this case, I want this service to manage my tasks, hence I'll start by cutting this tasks array from the tasks component and by instead adding it as a property still to the tasks service, like this. Now, however, I'll make it a private property by adding this private modifier in front of it, which is something you can do in TypeScript, so that it can actually only be used inside of this service. Because as a next step, I now want to add a couple of methods which can then be used from outside the service to get hold of tasks or add or delete tasks. Specifically here, I want to add a method called getUserTasks, which expects to get a user ID of type string as an input, and which should then return all the tasks that belong to the user with that ID. And of course, that is some logic we already have in the tasks component in this selected user tasks computed value here. So we can simply cut this code here and bring that over into our service. Now, this is not this user ID now though, but just user ID, this parameter we're receiving here. Now, in addition, I also want a method for adding a task. So here I add a method called addTask, which should get the task data as an input, and that will be of type new task data, using that type that we did store in the task model file. Hence, this import here must be added. And then inside of add task, we can add this logic, which we have in the tasks component, for adding a new task to this array of tasks. And add this here in add task in my service. Now I also need the user ID here in order to add a task, so I expect to get this, which is of type string, as a second parameter here. Then I assign that user ID as a value for the user ID property in this object. Of course, we also need a method for deleting a task, so remove task could be a fitting name, and here I expect to get the ID of the task that should be removed, which will be of type string. Again, we have the logic in the tasks component already. There it's this line of code that can be copied. So here I will overwrite my tasks with the new tasks where I removed one task. And with that, we outsourced all this tasks data management related logic into this extra class. Now, of course, we now need access to this class or to an object that's based on this class so that we can get hold of our tasks again. And therefore, as a first step, we should export this class so that we can use it somewhere else in our application. Now we can go to the tasks component TS file and we can import this newly added service here. So this tasks service, we can import it from the tasks service file. Now this is a class and therefore a blueprint for an object. So in order to interact with it and use these methods and so on, we actually have to instantiate this service first. And we could do that by adding a new property, potentially a private property, which is only meant to be used in this component class here, that could be named tasks service, and where we do then instantiate this tasks service like this. And then, for example, here, when we want to get our selected user tasks, we could do that by reaching out to this tasks service and by calling getUserTasks and by then passing this user ID to this method. But this approach has a huge problem. If we instantiate this class here like this, then we'll have one instance of this service in this component. But if we then want to use the service in another component as well, we would create a separate independent instance of that service there. We would not be sharing that one object that we create here. And the implication of that is that if we then change the data that's managed by that service in another component, those changes wouldn't be reflected here because we would be operating on different instances of that tasks service. That's why Angular gives you another powerful tool which is used in conjunction with services. And that's a tool called dependency injection, which is a quite common mechanism, especially when working with object-oriented programming. And the idea behind dependency injection is that you don't create this instance on your own, but that you instead tell Angular that you need such an instance, and you let Angular create it. And therefore, Angular can create this instance once, and you can then use this one instance in different components, and therefore you would then be operating on the same data. So how do we then tell Angular that we want such an instance? Well, for example, by adding the constructor function to this class, which is a special method which you can add to any class in JavaScript, which will automatically be executed when this class here is instantiated, which will happen automatically by Angular whenever this component is used in some template. So this constructor will be executed automatically, and it will be Angular that executes it in the end, because it will be Angular that instantiates this component. Therefore, you tell Angular about the dependency you need by simply adding it here as a parameter to this constructor. So here we could add this tasks service parameter, and by then giving it a type of tasks service, we let Angular know that we need this service instance here in this component. That's how Angular's dependency injection mechanism works. You specify your dependencies in your constructor function, and by clearly defining the type of the parameter you want, Angular is able to look up the class of that type and create it for you, so to say. Now, of course, to make this tasks service available in the rest of the class, we then have to store it in a property. And therefore, we can either bring back our private tasks service property, which is of type tasks service like this, and then set it in the constructor body like this, so that we store the received argument in this tasks service property. Or we take a shortcut that's offered by TypeScript, and we get rid of the property and the constructor body, and we instead add private, or public if it should be publicly available, but here private is enough, in front of this parameter. And that will then automatically create a property of the same name. It's simply a shortcut that's provided by TypeScript so that this common pattern of storing a parameter in a property gets a bit more convenient. And with that, we can then finally get our user tasks. However, we're not entirely there yet, because by adding this code, we let Angular know that we need an object of type tasks service, and Angular then will look for such a class, but it will not magically scan all your files and folders again. Instead, you need to register this tasks service, this class here, as something injectable with Angular, so that Angular knows that it can be injected and that it should look for this thing when encountering a dependency like we have it here. And we do register this class as injectable with Angular by adding another decorator to it, the injectable decorator, which is imported from @AngularCore. You add this by executing it like a function and by then passing a configuration object to it. And in this configuration object, it's this provided in option that should be set. And you should set it to root. Now, just as with all these other essential concepts, we'll dive deeper into services and dependency injection a little bit later in the course, but for most cases, it's this syntax here which you need in order to make a class, a service, injectable. By adding this decorator like this, Angular now is aware of this service and can create such an instance when you need it. And most importantly, it will only create and reuse one instance so that different components operate on the same object in memory and therefore on the same data. Therefore here, if you now save this, the app will not fully work yet, but if you select a user, you at least see those dummy tasks. And as you can see, they are fetched on a per user basis, and we only see the tasks of a given user. So that is working, and we are using that service. But now, of course, we want to use that service in multiple components, because that's one of the main reasons for adding such a service, that we can make our component classes lean and reuse that logic in different places of our application.